Thank you very much. Thank you for your flexibility, your adaptiveness, and for your mindfulness. So in the essence of time and in the essence of being mindful, like Alan said, we're going to try to give you the key points from our talks here. So they're becoming somewhat like TED Talks. Let's see. Oh, it's not. I don't know what happened. Okay. Is it this one?
Did you hit the key that toggles it?
Here? Like that? No? Do you want to open it on here maybe instead? Okay. Okay, I'm not going to touch anything. I apologize about that. So I'm going to get started. We at CREST, a team of myself and others, had the opportunity to evaluate Dragoon, which is a systems modeling intelligent tutoring tool. This was part of an ONR grant, so I'm going to tell you a little bit about the studies that we performed and the results that we got from doing that. So the main purpose and goals, or essentially main research question of our studies, was to evaluate Dragoon-based instruction. Essentially, we wanted to see how does this tool impact students' content knowledge in authentic classroom settings. And a secondary goal was, how do students perceive the features and use of the system, as well as the teachers. So let me tell you a little bit about Dragoon. Just one quick side note. John Wetzel, who's sitting in the front here, is actually here to demo that tool today. So if you have more technical questions and want to see it in action, go to the demo room for that later on. So just very quickly, it's a systems modeling intelligent tutoring tool. It has novel technologies. You can basically create content on there, both for assessment and instruction, and you can use various different domains. And it essentially helps students learn computer-based systems modeling and dynamics, as well as whatever content you pick to represent or choose to teach using the tool. It does that through model construction, so you can actually create models, and also by being able to interact with various components of a model or principles that are developed as part of the model. And basically this was in response to a need when we're talking about the Common Core standards. There's a push there for computational thinking, and also with the next generation science standards, there's a push there for systems modeling, especially when we're talking about the engineering practices part of next generation science standards. So let me just show you a couple of features here, and as I said before, John can show it in action. So Dragoon has an authoring mode where instructors and whoever wants to use it to author can create models and content. This is essentially what the authoring view looks like, where you can specify various types of information. You can create a problem statement. You can set a time in terms of how will the content be graphed, and so on and so forth. What's interesting is that the student view is similar, although here there's different type of feedback that comes into play. So if you look at this screen, you'll see there's some green parts, there's a yellow, and there's a red. And this is part of the feedback function in Dragoon, where the green means you got it right. The yellow means that you tried something, it didn't work out correctly, so the system essentially provided the answer for you, and the red is there's something correct. So obviously this sparks the students to go back and try to check their work and figure out what's going on. Here is another view, essentially a problem view. So this is often what a problem looks like. You'll see the nodes there, and similarly with the feedback, you might have a student go in and try to create a node and specify a node. and be able to create linkages between the other nodes. And you'll see here the different colors again. So if it's red and dotted, it's basically saying it's incomplete and incorrect. In the yellow, it's saying it's incomplete, but the system helped you out. And with the green, it's saying it's incorrect, but there's still something missing. There's something more you need to do. Here's just another view in terms of what you can see in Dragoon. So students have a chance to look at their data in tabular form, as well as in graphical form. And in terms of the feedback, you can choose when you're authoring how you want the feedback to be essentially not necessarily how it will be displayed, but when it will be displayed. So there's an immediate feedback option, which is where you saw the colors in the kind of the authoring boxes and on the nodes themselves. You can ask or specify in the system that you want a delayed feedback option, which serves a little bit more as an assessment mode or a test mode, where essentially students will be prompted when they try to graph. Their graph won't look necessarily correct. And so it'll prompt students then to go back and say, okay, my graph is a little bit off. I need to go back and reconfigure things, relink, respecify, so on and so forth. So here we go. I'm gonna quickly go through some of the results here. We essentially conducted 3 different studies. One was in an AP Physics classroom, and this one served a little bit more as a usability test. We wanted to see how does it work to implement it in the classroom, what kind of kinks do we see. Although we did collect pre and post data, it was a very quick cross-section snapshot, just one class. So we didn't necessarily see any pre-post differences there, but we got a lot of useful information in terms of how are we going to structure the next studies. Then we had study 2, which here we conducted a field test. The content or domain in this case was physiology. And here we wanted to, again, evaluate Dragoon and its instructional capabilities over a longer period of time, because we realized from the first usability test that we wanted to see, okay, how does it work when you try it out for a longer time, as well as provided more scaffolding in terms of structured workbooks, both for the baseline condition or the control condition, as well as the Dragoon condition. And the control essentially went through the same types of computation as the Dragoon condition did, only was like mathematical notation, whereas in Dragoon they used the computational modeling. And then the last study, again, was a field test where we wanted to replicate study 2 within a new domain, new context. So here we were working with AP biology students and ecology, specifically population dynamics. And again, it was for a longer period of time. And we were trying to use a little bit less information in terms of these highly structured workbooks and focus on making the workbooks for the Dragoon condition as well as the experimental condition pretty much identical. So let's take a quick view here at some of the results. So for study 2, which was the physiology domain, here you'll see the demographic breakdown essentially of the students. 95 participants, 45 treatment, 50 control. You'll also see here that most of them were enrolled in geometry. We were interested to see what kind of mathematical understanding do they already have that influences their ability to be able to understand the computational thinking, so on and so forth. And also programming is a key thing that helps us in terms of computational thinking. So we were looking for that as well. So nearly all of the Dragoon and control students had never taken any programming classes, and they had very minimal of the students had any programming outside of school. So quickly, in terms of the design and procedure, like I said, this was a longer implementation. We had a pre and a post on the first and last day. And essentially, the breakdown was that the teachers introduced systems modeling in general, the idea. Researchers introduced Dragoon. And then students collaborated on solving Dragoon problems, again, related to physiology. And in the control, the teachers introduced systems modeling again, the idea of it, and students worked on equivalent workbooks, again, in physiology. So here we have some results. So on one of the things we noticed on the pretest that there was actually a significant difference on the pretest score between the Dragoon and the control students, with the control students essentially performing lower. So we ended up controlling for that with the post-test results and using an ANCOVA. And in the end, we got an effect size of 47 and significant results. So essentially, Dragoon worked in terms of teaching students physiology content. And especially what we were focusing on for the content in this case was energy balance and blood glucose homeostasis. And then we have study 3. Here the sample was a little smaller. Again, we were focusing on AP biology. We had 41 treatment, 18 control, and we wanted again to look at some of these key demographic variables. Majority of them were 10th graders. Most of them were enrolled in trigger pre-calculus and the remainder in calculus, and some of the students had taken programming classes. Here the design and procedure were similar as to study 2, although the class times were longer and they were in block schedule. And essentially we had a pre and post that were at the same, essentially 40 minutes allocated at the beginning and end of the study, and students essentially worked through the content at their own pace. So similar to study 2 as well in terms of the procedure, the implementation was similar to study 2, although the researchers performed most of the tasks in terms of introducing the system, introducing systems modeling, so on and so forth. In terms of scoring, we created rubrics and had performed inter-rater reliability, as you can see there. And in this case, for study 3, the pretest scores were not different, which was a good thing, although we did find a difference in terms of motivational variable. We had a question where we asked students about how important is it for you to do well on this test, and we did find a difference in terms of the pre-test there, but we controlled for that again in an ANCOVA, and we also obtained significant results here with an effect size of 1. And I think that's probably about 5 minutes if I didn't go too much. So I'm going to just leave you with some of the overall things that we found. Students really enjoyed working collaboratively with Dragoon, both in groups as well as dyads. They really liked the feedback component. And I'll leave it to Alan to finish because I think I'm close to the end here with time. So thank you very much.